Welcome to Tricks for Maths. In this channel, you are getting videos based on Vedic mathematical tricks and techniques to solve various type of problems. From today onwards, you will be getting videos on Class 10 mathematical content of CBSE syllabus. That means I am going to provide videos to solve all the exercise what they have given in your textbook, Math Grade 10 textbook, with the explanation of the concept also, along with Vedic mathematical tricks and techniques. So you will be getting both type of videos, class 10 mathematical content as well Vedic mathematical tricks for different calculation. So please support as you have supported for the previous videos. Get the benefit of the coming videos which is based on Vedic mathematics as well as class 10 mathematical concepts. This is Sharda Hegde. According to your class 10 mathematical textbook of CBSE syllabus, our first chapter is real numbers. I hope you are familiar with number system. So these are the points they have covered in your textbook in the first chapter, real numbers, Euclid's division lemma, the fundamental theorem of arithmetic, revisiting irrational numbers and revisiting rational numbers and their decimal expansion. We will go through all these points one by one. We will solve all exercises what they have given in your textbook with the explanation of concept. So in our first video, we are starting with rational and irrational numbers because it is connected with your grade 9 concept. You have already learnt rational numbers and all. So in this our first video, we are starting with what is rational number and what are irrational numbers and how we are going to find the given number is rational or irrational. And then we will solve Euclid's division lemma, the problems based on Euclid's division lemma and also the problems based on the fundamental theorem of arithmetic. So don't skip, please watch till and you will get the benefit, you will get the solution for all the questions what they have discussed. I hope you are all familiar with the number system. If we consider it as a set, what are the different types of numbers involved in this set? Yes, we know the first one is, yes, it is natural numbers. We denote it as n, the set n. It contains 1, 2, 3 and so on. Right? These are the numbers. Belongs to natural numbers. Then comes, yes, whole numbers, right? So we denote it as W. It involves 0 as well, 1, 2 and so on, right? And then comes, it is integers which is having negative value also. We denote it as Z. The values are infinitely many negative numbers also and infinitely many positive also. So I'll write -3, -2, -1, 0, 1, 2 and so on. And then comes rational numbers. We denote it as Q. Okay, the numbers involving are fractions. Yes, so we can take any example for Q. It may be -3.9 and so on, 0 and so on, 5/6. So it is of the form P by Q, right? And then comes irrational numbers. We denote it as P, that you have learnt in grade 9. Okay, some few examples I am going to give is pi, √5 or √2, √3. These are all irrational numbers. But how will you find out which one is rational or which one is irrational? That we are going to learn now with few examples. Yes, we are discussing rational and irrational numbers. You know that rational number consisting of both integers and fractions, as well this integer is also involves whole numbers and natural numbers. That means if you get a number which belongs to any one of these group, it is called rational number. Other than this, it will go to irrational numbers. So I am going to give an example. For integers, it may be -3 or any number, negative value or positive value or 0. Okay, I can express as p by q. That means -3 is nothing but -3 by 1. Yes, I expressed as p by q, where p and q are some integers, right? Here fractions is nothing but yes, 2 by 4 or 4 by 5, whatever we can write, right? So it is also can be expressed as p by q. And even whole numbers and even natural numbers can be expressed in the form of p by q, where q is not equal to 0. That condition must be satisfied. Q not equal to 0. That means it should not be, the denominator should not be equal to 0. What will happen if it is 0? Any number divided by 0 is equals to infinity. Yes, so it should not be 0. This condition should be satisfied to tell the given number is rational number. So then what about irrational number? Any number cannot be expressed in the form of p by q, where q not equal to 0. This is called irrational number. This condition should not be satisfied. Then it is called irrational number. We will take an example to understand better this concept. Here are the 4 different examples. We will start with first one, that is 35 by 8. You are observing this number is in the form p by q, where q is not equal to 0. That means it is 8. Q is equal to 0. P by q, it is in the form where q is equal to 8 here. So it is satisfying the condition. So we can say this as rational number. And you have learned 2 different words in your previous class. That is terminating and not terminating but recurring. If the given number satisfies one of those conditions, you can tell that the given number is rational number. Yes, the first one is terminating. The second condition may be non-terminating, okay, non-terminating but recurring. So for the first example, 35 by 8, I can go for division method, right? So after doing long division, you will get your quotient as 4.375. That means the digits are ended here, right? That means it is terminating quotient you got. That's why 35 by 8 is a rational number. Now if you take 1 divided by 3, so what will happen? What will be the quotient? I need to take 0, 3 3s are 9, again it is 1, I'll take 0, again 3 3s are 9. So it will continue like that. Yes, you will get 1 and you will get 3 in the quotient. This is recurring. So this is also called a rational number. 1 by 3 is a rational number. That means in different example, we came to know that it may be terminating, or if it is not terminating, it may be recurring. In both the cases, the number will be called as rational numbers. Okay. So let us go for the second example. Here in the second example, we can divide. 4 1s are, 4 4s are is 16. So 3 is left over, 36. 4 9s are is 36. So you got 49 is the quotient, it's terminating. So this is also a rational number. Then what about root 2? Yes, we know that it is irrational, but how will you prove that root 2 is irrational? That we will learn in this session. Okay. Then 21 square. Yes, we can do that. It's a rational number and we can express it as simply as 21 square by 1, which is in the form of p by q. Yes. So a number is said to be irrational when it will not satisfy both of the condition. That means it is non-terminating as well as non-recurring. I hope you have understood. I'll repeat it once again. Irrational number is non-terminating and non-recurring. Okay, you know the value of pi, the nearest value we will take, okay, 3.14 and so on. The decimal places are infinitely many because it will not terminate. Also, we can't get a group of numbers or numbers which are recurring. Okay, so that number is called irrational number. And now we will learn how to prove root 2 or any other irrational number is irrational. Okay, let us learn that. Here is an example. Prove that root 2 is irrational. In order to prove this, we need to assume the contradictory. Okay, that means we should assume it is a rational number, because we know how to express rational number and when a number is said to be rational number and all, right? So let us assume that root 2 is rational. Okay, assume root 2 is a rational number. So how will you express root 2 then? Okay, root 2 must be in the form of p by q, where q is not equal to 0. Okay, here I'll take a and b, any two integers, and also they are co-prime. A new word came, co-prime. So what is co-prime numbers? Yes, you know that the numbers which are divisible by only 1. Okay, the number 1, that means common factor for both the numbers is 1, then that set is called co-prime. For example, 3 and 4, the common factor for these two is 1. Yes, any number, 7 and 8, okay, need not to be this consecutive numbers. Okay, 7 and 13 I will take. Yes, it is co-prime because the factor is 1 here. Okay, common factor is 1. So these are called co-prime numbers. Here also in this example we are assuming root 2 is equals to any number a by b where b is not equal to 0, because we are taking root 2 is rational number. Okay, so it must satisfy the condition a by b where b is not equal to 0 for some integer a and b, and also a and b are co-prime. Just I will write co-prime here, co-prime. Please note that a and b are co-prime. Okay, that means a and b is having the common factor as 1. Okay, now we can go for solution, squaring both the sides. Okay, I will write squaring both the sides. So root 2 square equals to a by b square. Okay, the next step, root 2 square means it is 2 only now. On the right hand side, a square by b square. Okay, now I can move this b square to the square. It is divided here. So if I move on the left hand side, it will multiply 2. So 2b square equals to a square. Also I can write b square equal to a square by 2. I moved these 2 on the right hand side. So I can say that 2 divides a square. This implies 2 divides a. Am I correct or not? Yes. Let me take any example. 3 divides 3. Yes. And 9. It is 3 square. It is also divisible by 3. Let me take one more, any example. 5. Okay. It is divisible by 5. Okay. 5 ones are 5 ones are. Also 5 square is 25. So 25 is also divisible by 5 itself. Similarly, if a square is divisible by 2, then a is also divisible by 2. Okay. So we got one conclusion. So the second step for the proof. Let me take or let me replace any value for a. That means I am now taking root 2 equals to some 2c by b. Okay, any other integer. So what will happen? Root 2 equals to 2c by b, where b and 2c are some integer and also co-prime. Okay, so squaring on both the sides. The same step we will follow. Okay, root 2 square equals to 2c by b the whole square. Okay, so it becomes 2 equals to 4c square by b square. Okay, so I can write 4c square equal to 2b square, right? Or in other words, I can cancel 2 here, right? So it becomes 2c square equal to b square, right? So I can write c square equal to, I will write here only, c square equal to b square by 2. That means 2 divides b square. Okay, 2 divides b square. This implies 2 divides b also. Yes, 2 divides a also, 2 divides b also. That means there is one more common factor for both a and b, that is 2. But what we have assumed? We have assumed that there is no common factor for a and b other than 1. Because a and b, what we have taken? A and b are co-prime. But here we got one more common factor, that is 2 for a and b. That means our assumption is wrong. Yes, what was our assumption? Root 2 is a rational number which satisfies this condition. Our assumption is only wrong. That means root 2 is irrational number. Okay, so like this we can prove that a given number is irrational by assuming the given number is rational number. I hope you have understood the method. In your textbook, exercise 1.3, first question is prove that root 5 is irrational. They have changed number. They have given few more examples to prove the given number is irrational. So we will follow the same steps, only the number is changed, right? So now we can assume that root 5 is rational number in order to prove the given number root 5 is irrational. So let us assume root 5 is rational number. Okay, so it must satisfy the condition that root 5 is equals to a by b, where b is not equal to 0, and for some integer a and b, for some integer a and b, and also they are co-prime. I'll just write co-prime here. Okay, for some integer a and b, and they are co-prime. Now the first step, how will you solve? Squaring both sides. Okay, squaring both the sides. What you will get? Root 5 square equals to a square by b square. Now you can write 5 is equal to a square by b square, and also b square equals to a square by 5. That means a is also divisible by 5. Divisible by 5. A square is divisible by 5. That means a is also divisible by 5. Now the second step, we can replace or we can take any other integer in the place of a. That means for some integer 5c I will take. Okay, for some integer a equal to 5c, How I can write root 5c divided by b? Only I replace the value of a. Okay, I have taken one more number here. So what will happen if I squaring both sides? The process is same. Okay, root 5 square is 5. 5c becomes 5c square means 25c square by b square, because 5 square c square, right? I will rewrite this. B square equals to 25c square by 5. So 5 ones are 5 5s are. That means 5c square is remaining, right? 5c square. Okay. Now I can write b square as, c square as b square by 5. So here it indicates b square is divisible by 5, right? It implies b is also divisible by 5, right? Again we can conclude a is divisible by 5 and b is also divisible by 5. But what we have assumed, a and b are co-prime. The common factor is only 1. But we are getting one more common factor which is dividing both the number. Yes, so our assumption is wrong. What was our assumption? Assume root 5 is rational number. So it must be irrational number. Like this we can prove root 5 is irrational number. In your exercise 1.3 will be 4 more examples. Only the number is different. You can solve by using the common steps. Okay, I hope you have found it very easy. Other concept like revisiting rational numbers and their decimal expansion, Euclid's division algorithm, as well as Fundal theorem of arithmetic. We will discuss all these things in our coming videos. Please stay tuned and you will get the consecutive videos on the single chapter, and we will cover all the chapters of mathematics. Yes, I hope you found it very easy. Please subscribe my channel if you are new to my channel. You will get the videos on Vedic mathematics along with this video. Please support by sharing with your friends and hit a like to my video. Till then, take care. Bye-bye.